All right, thank you. I will now introduce our guest. It is a great pleasure to present to you Joe Manning, who's the William K. and Marilyn Milton Simpson Professor of Classics and History at Yale University, where he's been since 2008, following many years at Stanford. He has a PhD from the University of Chicago, which is also his hometown, in Egyptology. He is a friend, a role model, a colleague for me. He is the author of 4 single-author books, including The Last Pharaohs, Egypt Under the Ptolemies from Princeton University Press, and The Open Sea, The Economic Life of the Mediterranean World from the Iron Age to the Rise of Rome, 2018. Among his many other contributions to scholarship, one that I will highlight very briefly is that he is the primary organizer and leader of the Yale Nile Initiative, which is one of the most important and serious projects in the world of the history of climate and society, bringing together paleoclimatology with historical studies, with serious modeling, and their sort of first major publication that came out of that project is the one that I have cited briefly today and then talked about a bit in the inaugural lesson that appeared in Nature Communication in 2018 on volcanic forcing and social violence in Ptolemaic Egypt. He is hard at work on a major new book on the history of climate change that will no doubt be a major contribution to the field, but he's taken a break from his writing to come and share some of his ideas and work with us today. So let's welcome Professor Joe Manning.
Thank you, that was long actually. Merci, c'est pour moi un grand honneur d'être ici dans cette place ce matin. Merci Kyle, et merci à vous d'être là aujourd'hui. I am jet lagged, so if you excuse me, I speak in English this morning because also my heavy Chicago accented French would torture you for an hour, I'm afraid. Okay. When I was a young boy growing up in Chicago, there was a television serialization of a Czech movie, Journey to the Beginning of Time. 4 boys tour the American Museum of Natural History in New York City. They get tired. They end up in Central Park in a rowboat. They row through a cave, and they emerge in the Pleistocene. And a lot of things ensue. They go all the way back to the beginning of time, eventually. They're okay in the end. It's a very clever movie that I had half forgotten about until the first time at the Desert Research Institute in Reno, Nevada, about 10 years ago now or so. And my childhood memories buried deep in my unconscious mind had led me here all along, I think. This sympathy for science and history together has been long for me, and paleoclimatology and history is extremely exciting for me personally for that reason. Now, I could not get away without mentioning this great man, being here, being greeted by Champollion, coming into the Collège de France, this place with so many great minds over the years that I have read since I was a graduate student and had long admired, especially Emmanuel Ladurie. In his inaugural lecture here in 1973, one of the things he said that I very much like is it's the geology of layers of rock beneath our feet he is more concerned about than the fascinating geography of discourse, which of course is crucial to any serious cultural history, but really he was already in the 1960s very much interested in scientific things. It's quite amazing, and of course, as you all know, his work has pointed the way to do this very difficult work, as Kyle, I think, has brilliantly illustrated this morning. Microhistories and macrohistories, both different scales, I think have to be done here. Environment as a kind of a constraint, climatic change as a force on production, among other things. It's hard to get it right in one book or one article, in fact. And time scale is actually really important. Interestingly, of course, as you all know, Leroy-Ladurie came back to climate and history in a much more forceful way with a lot more science behind him in his books that came out beginning in 2004. It's no longer possible, he said, for fashionable historians to sarcastically dismiss the new discipline as false science. The time for jeering is well over, and the present work now addresses the history of human climate, considering the impacts of climate and weather fluctuations upon our societies, particularly agricultural output, and in certain cases, epidemic disease. It's a very strong statement, of course, that he had come back to this wonderful field and in a much more forceful way with a lot more climate data that was beginning to come to the fore in the 2000s. Now, of course, we're mostly concerned with the Holocene. Not much happened interesting in the Holocene, according to a lot of paleoclimatologists. It's sort of a nice time to be humans and be in civilization, relatively stable climate coming out of the last ice age compared to what had come before. On the right side, the data goes right to left into the Holocene. On the other side, it's the other way. This is one thing that drives me slightly mad, maybe you all too, with climate science data. You have to make sure you're reading it in the right direction always. But it's the Holocene that we're concerned about, and Holocene climate variability. And as Kyle kindly mentioned, I've been working on this now for about 10 years with an amazing small group of people, and it's teamwork that has to happen with this, which is not how historians tend to work and tend not to like to work this way, but it has to happen. We need climate modelers, climate proxy scientists, historians, and ice core geochemists in particular. And we have a wonderful group that we are hopefully continuing to work on. And that's what I want to talk to you about this morning briefly. Some of our results, some of the ways we think about climate and history together in this Ptolemaic period in particular. A lot of climate proxy records now that are available to us, increasingly in higher resolutions, which is really important. Historical time, that is decades in years, not centuries and millennia, increasingly, and that really is important for us in particular with a lot of specifically dated historical information. Ray Bradley's Paleoclimatology, I don't know about you, Kyle, but this is by my bedside frequently. It's a fantastic textbook. We work, as I think climate historians have to work now, in what's called coupled natural human system dynamics models. This is a very simple version, similar to what Kyle showed you. Human systems and natural systems interacting, coupled with feedbacks in both directions. This is what makes doing this history extremely challenging, not very easy to do, and it's actually more complicated than that. This interactive coupled model gives us a flavor visually of how complicated it is to integrate the Earth system and human societies through some sort of time scale. It's extremely challenging, in fact, and very easy to get tripped up if you just use climate data to explain historical things, which is still fairly common to do. Now, of course, we're interested in the Holocene. We're interested in the history of the Nile River Valley, which turns out to be a very good instrument of understanding climate change on small temporal scales. The Green Sahara to the Desert Sahara, I was just at an amazing exhibit yesterday at the Musée de l'Homme with these wonderful drawings from Africa, from the Sahara especially. Really lovely to see that. This is an interesting part of the world because it's in part the origin of Egyptian civilization once the Sahara dried out and people moved increasingly into the Nile River Valley toward water. It really is a spark for Egyptian civilization to begin in the 4th millennium BC or so. So larger movements of people, larger time scales over 3,000 or 4,000 years from green to desert Sahara is one interesting time scale to study, and there's ongoing work here. Emmanuel Honoré here in Paris is doing wonderful work in the Western Sahara, for example. So in terms of structural continuities, I think this is really important at larger time scales, green to desert or desert to green back in time. It's a fascinating and very important period in climate history, of course. And a smaller scale, with Egypt comes, after 300 BC, a density of written records for the first time in Egyptian history. It's not a few or a few hundred, it's tens of thousands of specifically dated records, land sales, land surveys, all kinds of administrative texts, letters like here, that are often dated to a day in a month in a particular year. So it's very nice to establish an historical database of records that we're integrating into climate data that we're using about the Nile River. So that's the project. We've heard about volcanoes, and I never thought in a million years I would be so interested in volcanoes, but they actually are really fascinating things. And it's studied now very well. I won't go over the geochemistry, but it's pretty well established, the impact of large eruptions, not small ones, large eruptions that effectively reduce solar radiation reaching the Earth. It cools and it affects many things, including the monsoon system. So large volcanic eruptions are teleconnected to the Nile watershed. That's the language. This has been known scientifically since around 2006, so it's not so old, but it was news to a lot of Egyptologists when we were first doing our work that there's this connection between eruptions and the monsoon. It's not just El Nino, Southern Oscillation, ENSO, which is another important driver of Nile flood variability, but also volcanic eruptions. So this is short-term climate forcing. We're talking about a scale of year by year now, which is a scale that a lot of historians, including Laurent Ladurée, thought was not particularly important. It's half a century to a few hundred years to look at price fluctuations, for example. But we actually think even now, 1 year, 2 year time frames are important for understanding human societies and reactions to climate change. This is just showing you the mechanism or the result of the mechanism of large eruptions and the Nile River flow from historic river flood records, which we have quite a lot of after 622 CE or AD, an annual record of 1,300 years, which is one of the best historical records of climate that we have anywhere in the world. And large eruptions of the last 1,000 years or so. Katmai in Alaska, Laki in Iceland, Eldgau also in Iceland. In the 10th century CE, Nile River flows here consistently the lowest for a long period of time post these eruptions. So just visually showing us this connection between large eruptions, especially northern hemisphere volcanoes, and Nile River flow. It seems pretty well correlated indeed. Not the only forcing, but a significant one. And that's what we're looking at. Now, we heard today about conflict, and we have a lot of information about social conflict in the Ptolemaic period in particular. I wish we had more evidence earlier of social conflict. That may be important to know, but we have a lot of it for the Ptolemaic period, including the major revolt, I think the longest one in the ancient Mediterranean world, lasting 20 years, and the whole of Egypt is disrupted by this revolt. It's described in a lot of texts. It was violent. The Ptolemaic state had a hard time putting it down. Eventually they did, of course, with a lot of military force, in particular, new military garrisons and so on. So that's important. But it's always been explained, this revolt and a series of revolts in this period, as nationalist uprisings, anti-Greek. Egyptians did not like Greeks running Egypt, and they will revolt every chance they get. And we have a different view of the triggers of these revolts, which is Nile River flood failures. That's sort of the gist of our story, we think. Now, this is one of my favorite slides. This is the monsoon system around the world, the intertropical convergence zone. This is modern data, but it's proven that ITCZ is functioning like this in antiquity, just like this. The monsoon migrates north every summer around June around the world for various physical reasons, and volcanic eruptions prevent the monsoon from moving north because of weakened solar radiation or radiative forcing reaching the Earth's surface. So that mechanism is pretty well established now. And by the way, just as an Egyptologist in my old days, this is Egyptian history before the British dams were built in a nutshell. Annual response to the monsoon in East Africa and the flood that follows every year. That's Egyptian history, pretty much. I think it sums it up relatively well. Now, the details of the work are coming from natural archives, from climate proxies, and in particular from ice cores in the poles. Egypt is a place that does not have a lot of internal climate proxy records, not a lot of trees, for example. But we have ice cores from Greenland and Antarctica, which tell us a lot, we think, about Nile River flood flow, which is maybe surprising, but I think it's the case, and it's fascinating. So our early work that Kyle very kindly mentioned used the Nilometer record from medieval Cairo, from 622 to 1902, when the low dam at Aswan was built, and it's virtually an annual record of high and low stands of the river each year. Now, a lot of historians have discounted the value of the Nilometer record. It's problematic in some ways, but the statistics we've done on it, this superposed epoch analysis here in this graph, across the entire Nilometer record, 1,300 years, with the volcanic sequence in the ice cores, statistically show us that in the year of an eruption, it's you don't see the zero, but it's in the center there. The year of an eruption, we have this anomaly of flood consistently in that historical record, which we think tells us that the historical record is reasonably good because volcanic impacts on Nile flood were not known in the 7th century CE. So we think it's a reasonably decent historical record that we've then used for our work, and then we go backward. So this is me being a geek in Reno, Nevada, in the clean room, working with an inductively coupled plasma mass spectrometer, which gives us all this high-resolution data from ice cores now, measuring isotopes in the parts per quadrillion now, which is pretty spectacular. And that's why the data is pretty refined now for looking at volcanic eruptions that are recorded in ice cores. The sulfates circulate, they're precipitated down onto the ice, they form layers in the ice which can be analyzed chemically. And Reno, Nevada is an amazing ice core lab run by Joe McConnell in particular. And by the way, I think historians who use climate data should be spending time in labs to understand how this works, where the errors are in this kind of data, and so on. I think it's really instructive to spend time in climate science laboratories. So these are some of the results we've done. The top in the blue are the volcanic eruptions from Greenland and Antarctic ice. On the left is the Ptolemaic period. The one that's dated 44 BC is now dated winter of 43 BC. I'll tell you more about that in a couple of minutes. What's interesting about the Ptolemaic period versus what we call the Roman Quiet period is the number of volcanic eruptions in the last 3 centuries BC. There are 16 eruptions the size of Mount Pinatubo or more. Mount Pinatubo is the last eruption in 1991 that impacted global climate significantly. So there are 16 versus 1 volcano in the first couple of centuries CE. I'm not going to make too much of an historical theory about it, other than the Romans get kind of lucky, at least with volcanic eruptions. And the Hellenistic world gets really unlucky. This is a very active period versus a very quiescent period in the first 2 centuries CE. And we're living in a quiescent period now, by the way, because Pinatubo is the last one in 1991. It's an interesting sequence. We have the eruptions. We can measure the size of the eruptions. We can measure the reduction of solar radiation and the impact on the river flood now pretty precisely. And we have a lot of historical records that we think make sense in this sequence as well. So we can begin to tell, I think, a richer story of the interaction of human beings and a very short-term climate shock year by year. For example, a text I think we've already seen, the Sakia, this kind of ox-driven, usually, compartmented water wheel to lift water onto land from the main river channel. It's a photograph in 1941. These things are still around, although pumps now are more common. These are machines introduced into Egypt in the 3rd century BC, which is interesting. I think the result of the Alexandrian library and the geniuses there, but also the result of the pressures, I think, on the countryside with pretty poor now flooding for quite a bit of the time, we think. On the right is my favorite letter on papyrus. It's called Papyrus Edfu 8. It comes from a temple town in southern Egypt, and I'm sure, not probably, I'm sure it's dated middle of the 3rd century BC. It's a letter to the king from Philotas, who's a fire signaler, which is a kind of a guy who makes smoke signals to signal, typically to signal the flood volume is coming. The flood is beginning down river. He's also a soldier at Edfu, and he tells us for a long time there's been no flood. And he wants to inform the king of a certain machine or a certain technique. The Greek word is techne. It could be either a particular machine or a method, a technique, perhaps, which does no damage, but by means of which the country may be saved. Since during the last 3 years, the river has not flooded. I think that's significant, and that's why I date this text middle 3rd century BC. The dryness will produce a famine, that text breaks off. But if you wish, this year, right now, will be a good flood again. Amazing. He asked the king to have the local governor give him 30-day meal ticket, food for a month, and to send for him quickly so we can go to Alexandria, presumably, and show the king this new machine or this new method himself. It's a very strange text, actually. And you have to wonder, why isn't this person just doing the work in the fields? Why is he writing the king for a meal ticket to show him this advice, this new machine, to advise the king, I guess? It's an old world. I think it's an old model of you petition the king because that's how this society works. It's quite old-fashioned, I think, in some ways. But it shows us a pretty serious time in the middle of the 3rd century BC, which we think is volcanically related to the first revolt that we have, where we know there was 3 years of Nile failure, and the Ptolemies have to ship grain back into Egypt from external land, which is remarkable indeed. It was a very serious crisis, and the most important war, by the way, in the 240s was stopped at the point where the Ptolemies were about to put paid to their rivals, the Seleucids. But Ptolemy had to shut the war down, return to Egypt to put down this revolt and bring food into Egypt to sort of save the day. It's remarkable in the 240s. We also think the 160s BC is an important decade to look at. There's a lot going on, including another war, the last of the big ones with their rivals, the Seleucid kingdom in the Near East. Antiochus invades Egypt twice, in 170 and 168 BC. At the end of this decade, the Ptolemies create a new fiscal arm to collect taxes in a more organized way, the idios logos, the special account it's called, by the latest 162. I'm sure that's a response to the problems, the dynastic disputes, another priestly decree which seems to be always coming at the end of a crisis point. The Rosetta Stone, the famous one, is an example of this, but they all are coming after periods of crisis, it seems. And in 165, in the middle of quite a lot of chaos, there is a large text called On Agriculture, which mentions now flood failure, a lack of water, abandoned land, forced leases of land in order to solve an agricultural crisis at the level of the state across Egypt, leases of land at reduced prices to get production back, and the high official, the head of finances, calls the situation a calamity throughout Egypt. So this is another crisis point, clearly, and there's a lot of interesting text. Just one example, a woman writes to her missing husband in 168 saying, "Where in the hell are you? We're here at home and we can't eat, and the price of wheat has gone extremely high, and you are missing. You haven't come home," for example. A lot of text like this in the 160s. It's really, it's a crisis point in Ptolemaic history. It's also a crisis point in Eastern Mediterranean history, including Rome coming pretty fiercely east. It's the time of the Maccabean revolt, for example, in Jerusalem as well. So it's an extraordinary decade, which we think has a climate component to it. So this is how we're working. Again, this is the kind of a visual representation of volcanic eruptions, and then we can map, and this is just visual, not statistical, of course, things like wars, the shutting down of wars, the priestly decrees that I mentioned, for example, in these decades. And this is essentially what we're doing, is working at the scale of decades now, because I think we can do that. And it's the 240s, it's the 160s, it's this big Theban revolt from 215 to 186, and then it's the late 40s BC, which is probably a horrible time to be in the Eastern Mediterranean. That's what our project is doing this last year, is coming up with decadal level stories. What's fascinating about the 160s also is in the same year, well, a year afterwards, of the On Agriculture panicky letter from the head of finances to all his officials in Egypt saying, get land under cultivation any way you can. And the language of that text is rare. It's actually unique. It's actually sort of foul language, official yelling at lower officials saying, get to hell to work. Very similar thing in China in the same year, for example. Again, we don't know what's going on with agriculture, but something significant statewide is going on in Han China in the 160s. I think it's the Eastern Asian monsoon, but it's part of the same monsoon system that was suppressed, probably for a few years. One more interesting text. From the 3rd century CE, the Oracle of the Potter. It's actually a copy. We have 4 copies of this text from the 3rd century AD or CE, but it's talking about the 160s, BC. So it's copied and copied for whatever reason. It's called the Oracle of the Potter. And here it is, part of it. The river doesn't have sufficient water. It's not flooding. The land is scorched, but unnaturally dry. The sun will darken as it will not be willing to observe the evils in Egypt. The earth will not respond to seeds. The farmer will be pressed for taxes for what he did not plant. There will be fighting in Egypt because people will be in need of food. The king will come from Syria. This is Antiochus IV in 168. He will be hateful to all men. The country will be in confusion, and many inhabitants of Egypt will abandon their homes and travel to foreign places. The text goes on. It gets worse. Now, this text is almost universally interpreted as an anti-Greek text. The Ptolemies hate the Greeks running Egypt, and they want an Egyptian king to replace the Ptolemies in Alexandria. But we have a very different interpretation, our project does. It could well be literary, and there's literary interpretations, that's fine. But if you read the text literally, It's describing, I think, volcanic impacts on the Nile River flood. The sun will darken, not because the sun god's embarrassed. No, the sun actually is darkened. It's a volcanic dust veil, if I'm not being crazy about volcanoes. It gives us the mechanism, this text. No flood, soil is dry, darkened sun, seeds are not growing, the farmers are stressed out, unable to pay their harvest tax. By the way, the taxman's coming, looking for taxes, the text says, and the farmer can't pay. The crops are stolen. There's internal unrest. There's invasion by Antiochus IV, the only invasion into Egypt from the outside in the 3 centuries BC of Ptolemaic control. There's migration. There's murder, the text says. Alexandria is laid waste. The text wishes for a return to the ancient capital of Memphis. A good king comes. The flood returns. The winds will be well ordered. It sounds to me like it's even what happens with the monsoon coming into Egypt. There's a reversal of the winds in Egypt coming off the Mediterranean at the same time, which is really interesting. It gives us, in other words, the entire mechanism here as a literary text of what happens in Egypt in volcanically impacted years, or a sequence of volcanic eruptions indeed. That's how I would interpret this text. Just straightforward, it's telling us what happens, and it's relatively ugly, to be sure. So the 160s, there's 4 eruptions in the 160s. This is why we like decades, because there's not one eruption. Usually there's several eruptions, and there's 4. One tropical eruption, possibly Indonesia, we don't know often where these are, we just know relative location, and then 3 high north latitude eruptions in sequence. And from the Babylonian astronomical diaries from the Near East, which is another fabulous historical record of climate, here we have time series of commodity prices, 6 different commodity prices. We can begin to map Nile flood failure, severe cold in Babylon, volcanic dust veils, the end of the 6th Syrian War, right the year after the tropical eruption, onset of revolts, land grants to soldiers to get land under cultivation, and royal edicts, a whole series of them. Now, this is just visual again, of course. We need statistics to sort of tie this together, but it's interesting that there's a lot going on in the 160s in terms of state-level responses, but also individual responses, even literary responses to what's going on. That oracle, the potter, is an old Egyptian philosophy that good kings control the climate and the harvest and political stability. But the reverse also holds. If things are very bad in the country, there's instability, there's crop failure, there's no flood, it means the king is bad. So it's not anti-Greek, it's anti-current king who happens to be Greek. It's a subtle difference, I think, of what that text is telling us, what's going on. We've also produced a climate model for the 160s. We're doing one, as I speak, for the 240s. We've also done one for the 40s BC. And we can understand the solar radiation reduction. We can understand the impact of drought in that decade, for example. It's not just in Egypt, but it's Indian Ocean monsoon-wide. It's also in South Asia. I'm sure if we had texts from South Asia in the 2nd century BC, we would have a similar story of monsoon failure. So this is remarkable things that one can do with climate data, and it seems to fit the historical story, we think, relatively well. Now, the most controversial work we've done possibly is the Okmulgee eruption in Alaska in 43 BC, which Roman historians tend not to like a whole lot. It's the largest eruption in the last 2,500 years. It produces, from tree rings, we know, the 4th coldest decade in the last 2,500 years, the 2nd coldest year in the last 2,500 years. The temperature departure from the background is about a decade long. It's not 1 year or 2, which is typical of one eruption, but it's a decade-long impact. And you'll see, also, it's a more complicated story than one eruption. There's a second eruption, a first one just before the large eruption. This actually works. I'm usually clumsy with this. That's this Alaskan eruption that's been identified now with tephra analysis. We can't always identify which volcano and where it is. It's important that you do that, though, because the climate impact has to be understood by the kind of eruption and where it was located. And so the tephra, the glass analysis, is getting better at actually fingerprinting particular volcanoes. Okmuk in Alaska had a long eruption history. Volcanologists thought it erupted sometime in the 1st century BC. Then it was 44 BC as a guess, but that's actually Etna, which is erupting in the Mediterranean in 44 BC. Okmuk is a different creature, much larger, huge impact on the climate. And it's now dated, because of Joe McConnell's lab in Reno, January, February 43 BC. That's how specific the dating can be now. It's seasonal, it's winter, and that matters because it's going to impact the Nile flood, we think, starting in June that same year. If it erupts in June of that year, it's not going to impact the flood that year because the Nile's already in flood, as it were. So we think that's really important, and the fact that Joe McConnell can date that specifically is marvelous. So there's a lot going on in the age of Cleopatra in the 40s BC, including cold before Okmuk for whatever reason. So the climate story is not just about Okmuk, of course, but Okmuk really has a large impact on the Nile River and a lot of other places on the north part of the Mediterranean as well, where it's very cold and very wet for several years in a row. We think that impacts the Ptolemaic kingdom. Our historical records tell us that the Nile flood is failing for several years in the late 40s and the 30s BC, but it's also impacting the north part of the Mediterranean and South Asia and China in the same years. In the late 40s BC, there's a very large-scale famine in China. Now, one more thing we can do in our project is we can model the hydrology of the Nile River now, which is the first time that's been done, and it's remarkable given it's the most studied river in the world, that we have now specific climate hydrology models of river flow. And it's based on historical records and, of course, modern topography of the Nile River floodplain. But what's fascinating with technology now is, and this is the work of one of my former grad students who's now going to be working with Kyle in Oklahoma, Joe Morgan, we can map here every town and village in Egypt because of the papyri, which is pretty nice. And you'll notice here, well, it's kind of hard to see, but you can see villages almost always, it's sitting on higher lying land, which in ancient times, that's where villages are, slightly higher above the floodplain. They're still high above the floodplain in a modern floodplain topography, which is rather interesting. That tells us we think that the floodplain hasn't changed that much in 2,000 years, I think. That's pretty nice. And you'll notice the blue is water. We can do now different scenarios, and we can input volcanic eruptions and look at where water hits the floodplain and where water doesn't hit the floodplain. We hope we can begin to have a regional story in Egypt then with impacts like volcanic eruptions on the East African monsoon. Some places may get water, other places don't have water. That's a regional story of impact of drought, we think. And that might be interesting to explore. This is brand new data. No one has seen this yet, by the way, except you all. And we're really excited about it because there's more to come from our hydraulic modeler at Ohio State University, Jim Staggy, who is quite brilliant at doing this. This is our model from the Okmuk eruption, by the way, which shows you it's wetter in the North Mediterranean, it's drier in the East African monsoon area. So we get wet, cold in the north, in the Mediterranean, in the Roman world, and we get dry East Africa, Egypt in some bit of crisis. And of course, Egyptian grain is important for Rome in this period. So they are connected that way. So that's the model of Okmuk. We think it's really significant. We think it had to have had impact on Rome as well. What we don't have, of course, is a nice series of grain prices from this period. So it's a circumstantial story, but we think there's more to explore. So what does all this mean for doing history? And I think we heard some of this already from Kyle. Societies are complex adaptive systems, of course. The loss of complexity tends to be telling us there's a loss of adaptive capacity, but not always. I think small-scale societies do better with shocks in many cases, so that's an important thing to think about. Mitigation and technological responses, I think we see both of those in the Ptolemaic period already, and movement and migration and internal unrest. I think all those things seem pretty clear in the historical record from the Ptolemaic period. And now we can understand this on the scale of a year or a decade, and not just having a fuzzy idea of now river flooding, and maybe it has something to do with political instability. I mean, this is Karl Butzer, the brilliant geoarchaeologist who more or less founded the field in the 60s. He did a lot of work on now river variability and political history, but without much scientific data, because it didn't exist in the 1960s. Now we have a lot of scientific data. We think we can do something better historians. So just let me conclude. The Ladoury, in his inaugural lecture here, talked about Histoire immobile. He's talking about peasant mentalities, I think. He was talking about Languedoc for a couple of centuries. The inability of the farmers there to increase productivity of the land. And he concluded, some have spoken of a natural ceiling on productive resources, but nature in this case is actually culture. It is the customs, the way of life, the mentality of the people. It is the whole formed by technical knowledge and a system of values, by means employed and the ends pursued. It's Histoire immobile in that sense. The mass of people are not changing very much. Elites are changing a hell of a lot, of course, always. For the rural population, I think this is true in Egypt. It is a Histoire immobile as well. But I think paleoclimatology and climate modeling can give us historians the ability to see societies of the past in a different way. Histoire en fuite, possibly societies on the move, societies responding at every level, individual farmers, even inventing things, apparently. Inventing new techniques, certainly at the level of state with fiscal responses, even with food supply. We know that happened in the 240s massively. We know that happened in the age of Cleopatra after Okmuk, opening up the royal granaries to feed a population that was on the verge. So I think Histoire en fuite possibly is another way to think about things. Je vous remercie.